David Smith here with another Flip Classroom math video. A few tips before we start. Remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain them. Finally, you could turn on the captions and read my words below on the bottom of your screen. Today's topic, Chapter 2 Review. I'm going to go through some example problems of the kind you might see on a test or a quiz, something like that. So one of the problems I notice that students struggle with is one of these types. It says, express 1188 as a product of primes in index form. So that's kind of a confusing instruction if you don't quite get it. What they want is they want prime numbers raised to powers times each other that would ultimately make 1188. So I have a really methodical way of doing this, and I want to share that with you, okay? So what I do is I start dividing by the lowest primes. Can I divide 1188 by 2? Sure I can. I don't have these numbers memorized. So when I pull out my calculator and divide 1188 by 2, I get 594. Now that's even. I can divide by 2 again. Let's just keep doing that. So 594 divided by 2 gives me 297. Now that's odd. I can't divide that by 2, but if I pull out my calculator and try to divide it by 3, I find out that I can. 3 goes into 297 and leaves us with 99. Now 99 is odd. 99 is also divisible by 3. 99 is 3 times 33. Okay, so I'm breaking it down. 33 is also divisible by 3. That's just 3 times 11. Now, 11 is prime, so we are done with that. Now I have all of my factors. I have 2 times 2 times 3 times 3 times 3 times 11. That will get us all the way back to 1188. So now, so let's write that out. This is going to be 2 times 2 times 3 times 3 times 3 times 11. I just used this one, this one, this one, this one, this one, and that one. Okay? So that's our prime factorization of 1188. Now we've done half of this as a product of primes. We've done that. Now we need to do it in index form. And that's not too bad. I have 2 times 2. This is 2 squared times 3 times 3 times 3. That's 3 to the third times 11. So there we go. It's 3 primes, 2, 3, and 11, and 2 of them have powers on them. So it's 2 squared times 3 to the third times 11 makes 1188. And if you want to check your work, you can just pull out your calculator and do that. Put in 2 squared times 3 to the third times 11. You should get 1188. Okay, let's do a few more problems. But before we start, here is where we're going to start using all those index laws that you learned in Chapter 2. So if you have a cheat sheet with those laws, you want to get that out, or if you need to review those laws, you're going to get that out. I'm not going to go through each law and explain how it works. I'm going to do problems that use those laws. So I have videos that explain all those laws and do example problems. If you need to drill back into those to master this, please do that. Okay, first problem. Here we have c to the third raised to the fourth. Whenever you have a power raised to a power, you multiply the powers. So this becomes c to the 12th. Pretty straightforward. Okay, now we have addition. We're not going to multiply powers, but what we are going to do here is we're going to figure out what these things are. 3 to the 0 is just 1. Remember, that's the 0 power rule. Anything to the 0 power, I don't care how simple or complicated or big or small, anything to the 0 power is just 1, plus 3 squared, well that's just 9, so that's going to give us 10. So the answer to this one is just 10. This one is a little bit more complicated. I've got a fraction, so let's simplify this. Notice how the bottom here, I have another power of powers problem like this one. So I'm going to carry the top over, x to the 15, and this is going to become x to the 2 times 5, which is x to the 10. Now we had another rule with quotients. When we have the same base, then we can do this. This becomes x to the 15 minus 10. Remember, if it's underneath the fraction bar, you can bring it up and change the sign. So this becomes x to the 5th. Okay, that's that one. Now, you might see a problem that's written like this one. Express the following as a power of 2. And this does not look like a power of 2 at all, but guess what? We can manipulate this so that it will. Let's check this out. What's 8 as a power of 2? Can we do that? Yes, we can, because 2 times 2 is 4, times 2 again is 8. So that's 2 to the third power. So I can rewrite the top as 2 to the third, then bring that squared over. So it's 2 to the third squared. 4 is a power of 2, because 4 is just 2 squared. So I can do this, 2 squared to the third. Now that's going to give me, because now I have powers of powers, like we've done over here. 2 to the third squared is going to be 2 to the sixth, that's the top. And 2 squared to the third is also 2 to the sixth. So now using this rule with the fractions, I can do 2 to the 6 minus 6, which is 2 to the 0. Now, you know from this problem here, 3 to the 0 is 1, that this equals 1. However, the instruction is express as a power of 2. So we need to leave it as 2 to the 0, even though we know that's 1. Okay, let's do a few more. Sometimes you'll get instructions that say, write without brackets or negative powers. A little bit of vocabulary. Brackets could be parentheses or square brackets. They could be like this. These are square brackets. They could also be parentheses. That's what that word is all about. And then powers. Remember, powers are indexes or exponents. We use all those 3 words interchangeably. Okay, so here we have a negative power. From the exponent laws, we know that you can just move it down to the bottom of a fraction. This is 1 over x to the 4. So x to the negative 4, 1 over 3 to the 4. Okay? So, and now we can do 3 to the 4. That's pretty simple. That's 1 over 3 times 3 times 3 times 3, which is 81. 3 to the 4th power is 81. Now you can do that on your calculator. You can probably do that in your head. You might also get a feel for some of these numbers because you've bumped into them more than once. Okay, now this one, 3/8 to the negative 1. I'm going to rewrite this out in a bunch of steps just to make it super clear. I can take this power and distribute it onto the 2 numbers. So this becomes 3 to the minus 1 over 8 to the minus 1. Okay, so far so good. I still have some negative powers. So I can just switch these. You can change the sign of anything to a power and move it to the top or to the bottom. So this becomes 8 to the 1 over 3 to the 1. Now, in this case, the 1s are superfluous. They're not needed. 8 to the 1 is just 8, and 3 to the 1 is just 3. So this is 8 over 3. Okay, let's do this last one. A to the negative 2, b to the 3. So I've got multiplication here. This is just going to let me do b to the 3, bring this one down, a to the 2. And we're done with that. Okay, these last problems have a certain instruction that you do need to follow. Evaluate without a calculator. So you can put these 2 things in your calculator. At least some calculators will allow entries like these type of fractional and negative exponents. Others won't. But if you have it, you can do that. It's going to give you an answer. But on a test, these problems are pretty hard to do do by hand in one step. So if you get a test question like one of these with that instruction, make sure that you show steps. You can use your calculator at the end to verify your answer, but if you don't show steps, certainly for me, you won't get full credit if you just write an answer. Okay, so fractional exponents. Here's how that works. The 1/5 power is the same as the 5th root. So they're asking for the 5th root of 32. So that means what number times itself 5 times makes 32? And 32 is not super big, so that number has to be pretty small. So obviously 1 won't work because that's 1 times 1 times 1 is still going to be 1. So let's try 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 more is 32. So the 5th root of 32 is just 2. Okay, let's do this one. This one's a little bit more complicated. The negative 1/2 power. So let's get the negative off of that. So that's our first step. That's 1 over 100 to the 1/2 power. Now, if you remember from your index laws, the 1/2 power is the same as the square root. So this becomes 1 over the square root of 100. And now we know the square root of 100, that's just 10. So this is 1 over 10. Now that you've watched the video, take a moment and write down any questions that you might have so you can bring them to our next class. Remember that you can always watch the video again and perfect your notes. Finally, if you enjoyed the video, please click the like button down below. And if you'd like to help me grow my YouTube channel, please click subscribe.